Hey guys, Mr. Betts here. So let's look at a couple examples where we're finding the average value of a function on an interval. It's really a pretty straightforward process. You just have to know the formula that we're using. So remember that the average value is equal to 1 over b minus a times the integral from a to b of our function. Okay, so we're taking the area under the function divided by the width of the function, and we're finding essentially that average height of the function then. So for this particular example, the average value is going to be 1 over 3 minus 1 times the integral from 1 to 3 of x squared with respect to x. This is not a calculator question, so we do need to evaluate this by hand. So we'll just have the 1/2 out front. Antiderivative of x squared is going to be x cubed over 3, and that's going to be evaluated from 1 to 3. Really, that 1/3 could be factored out and can go with the 1/2. So this is going to be 1/6, and then 3 cubed is 27, minus 1 cubed is 1. And so we get 26 over 6, which is 13 over 3. I will say that if this were a free response question on one of my assessments or on the AP test, once we get to the numeric answer here, that would be an okay place to stop, box your answer, and you're done. If you do make a mistake while you're simplifying your answer, you will be docked points for that. The second example here, we're doing the same thing. So the average value is going to be 1 over b minus a times the integral from 0 to 1 of sine of x squared dx. Now, I want to point out that this has to be a calculator problem because this integral right here we cannot evaluate by hand. Sine of x squared is one of those functions that I talked about that does not have a closed form antiderivative. And in order to evaluate this definite integral, we need the antiderivative. So the alternative is using technology to help us out here. So we're going to plug that into our calculator. On a TI-84 graphing calculator, you can put this in as y1, and then you can use the integrate function on your calculator to integrate from 0 to 1. That's going to give you a value. In this case, we don't have to divide by anything because this is just 1. So that integral is actually going to be our answer. So that's going to be 0.310 rounded to the nearest thousandth. Remember, calculator answers should be accurate to the nearest thousandth for your final answers. And since this is a final answer, we don't have to worry about storing that for later use. If we were going to use this as an intermediate value to get another answer later, we would want to store this value in our calculator to get all of the accuracy that the calculator gives us. We don't need to do that here again because that is our final answer.